So this video we're looking at plotting reciprocal graphs, which is again following on our work from plotting quadratics, and hopefully we now know that a quadratic that looks like this, so this kind of happy face, it's going to be in the form, or the basic form is roughly y is equal to x squared. We also looked at that if it's going a reflection in the x-axis, right, it is similar, but it is equal to y is equal to negative x squared. We looked at cubics, okay, which again, in its kind of most basic form, if it's kind of like in this S shape, that's going to be a cubic. It's going to have a power of 3. So a quadratic has the highest power being a square. A cubic, the highest power is a 3. And we also saw that a cubic, it could be kind of going in the opposite direction, S shape, if it is a negative. So if it's something like that, it would be y is equal to negative x cubed. Today, we are looking at reciprocal graphs. Okay, so reciprocal, we might know this, right, from our work on perpendicular lines and just reciprocals in general. Reciprocal means 1 over something, where in this case that something is x, and if we give it equal to y, it plots the graph that is in the shape here. So this here is the basic shape of a reciprocal graph, and that's really important to know, right? Because when we go and plot our table of values, so we'll go through 2 examples, right? If we recognize something like here, we've got 2 over x, okay, we need to be able to recognize, right, that is a reciprocal graph. So it's going to look something like this. Okay, the second one is a bit trickier because it's 10 over x squared. It is still a reciprocal graph, but it's a trickier one. But anyway, if you just roughly know that it's going to be in this shape, that's useful. Because when you plot your values, if one point is massively wrong, okay, you should know roughly that, well, y is equal to 2 over x. Okay, well, it's over x. It's going to be a reciprocal graph. It should look something like this. Okay, let's begin. So again, the table of values between -4 and 4, that just means, well, our x values are down here, our y values are up here. We're going between -4, which is down here, up to the point of 4. I've got to put in these x values into my y equation. Let's do that. So the first one, we can go and say when x is equal to -4, I'm going to get y is equal to 2 over, so 2 over my x value, x is equal to -4. And let's put it in using a bracket, because substitution is always good to use a bracket. And here you could use a calculator if you're being really lazy, but right, what is 2? What's 2 divided by 4? Well, 2 divided by 4 is equal to a half, or 0.5, but it's 2 divided by -4. You've got one negative there dividing, so it's going to be negative 0.5 is your first y value. So when x is -4, y is equal to minus 0.5. And we keep going. So when x is equal to -2, we put it into our equation, so y is equal to 2 over x, where x is equal to, but is equal to -2 in this case. 2 divided by 2 would be equal to 1, but it's 2 divided by -2, so it's going to be -1, is my second y value. When x is equal to -1, when x is equal to -1, what's going to happen there? Well, y is going to be equal to 2 over my x value, which is -1. 2 divided by 1 is equal to 2, but 2 divided by -1 is going to be equal to -2, which is my next value. Good. Something very interesting happens when x is equal to 0. Let's consider it and be very careful here, because when x is equal to 0, if I do y is equal to 2 divided by x is 0, well, in maths, you cannot divide through by 0. It is an illegal move, okay? If you do this on your calculator, it might say something like error. Okay, that might pop up. And you just can't divide through by 0 maths. It is not something you can do. You can do 0 divided by a number. That does exist. That is equal to 0. But that is not the case here. We're doing 2 divided by 0. It is, and really right, we say it is undefined. That means there is no value. It just doesn't work. It just does not work. So error, undefined, you can't do it. So when x is 0, y is just equal to nothing. It is undefined. And we keep going now. When x is equal to 1, these ones should be relatively straightforward because our numbers are positive. We get y is equal to 2 over x, so 2 over 1. 2 divided by 1 is equal to 2. So that's a nice and easy one. When x is equal to 2, y is going to be equal to 2 divided by my new x value, which is 2. 2 divided by 2 is equal to 1. And when x is equal to 4, y is going to be equal to 2 divided by 4, so 2 over 4. I'm not using brackets here. I probably should do, I guess, but positive numbers, it isn't as important. 0.5. Sorry, 1 and then 0.5. Okay, good. So what's important to note is when I plot these points here, they should kind of roughly follow this shape here. So kind of this curve up here, this curve down here. If not, there's a mistake somewhere. So let's plot these points here as coordinates. So x minus 4, y is minus 0.5. So somewhere down here, roughly. Minus 2, minus 1, minus 2, minus 1 is here. And then 1 minus 2 is down here. And because I'm kind of stopping, if I kept doing like, if I did like minus 0.5, I would then get a value which is down here, somewhere down here. Okay, but I stop there. But it does follow this first part of the shape here, which kind of begins over here, and then we go down, and we go to here. We don't stop there though, because we know, right, the graph keeps going down, and then really importantly, right, and this is important, it doesn't ever touch the y-axis. It gets very close to it, but never touches it. That is really important, and we'll go through why that is the case in a second. And the second part of the graph, we've got x is 1, y is 2, so 1 and 2, which is up here. We've then got 2 and 1, which is here, and we've then got 4 and 0.5, which is down here. And again, that is good, right? We connect those together. We get this, which matches this part up here. Okay, but it would keep going on forever and ever, but it would never, ever, ever quite touch the y-axis. And the reason is, and this is a bit beyond what you need to know, but we're really saying when x is equal to 0, if I go and draw this in blue, okay, so when x is equal to 0, x is equal to 0, well, we saw down here, there is no value. It doesn't work. So we actually say that this line here, because there is no, it doesn't work out, we call this, and this is beyond what you need to know, but I'll tell you anyway, it is called an I can't even spell it, sorry, asymptote. That is spelled incorrectly, I think, asymptote. I'm really sorry, my brain is frazzled, but basically, right, it just means that your two curves here will never ever touch the line x is equal to 0. So really, right, if you were going to do this at a bit of a high level, this line here is your line x equals to 0, which is hard to see because it lies bang on the y-axis. Okay, you don't need to draw this in, okay, but just to make us aware that that's what's going on there. So the curve gets really, really, really close to the asymptote, but never touches it. That's important. And you've also got one going in this direction, okay, at y equals to 0, because the equation, if y equals to 0, then you can't solve for x. It doesn't make sense. Anyway, that is a bit beyond the scope for the time being, and I'm actually going to remove this so we don't get confused. If you kind of skipped forwards and you're thinking, what are those blue dots? I will get rid of those. But we just need to know at GCSE level that the basic shape, okay, is as seen here. So sort of two curves, finished, and that is it. Which, to confirm, is what we've got over here. Good, reciprocal. Something over x. Good. Example 2 is a bit more challenging. It is still a reciprocal graph because it is a number over, in this time it is not x, it is x squared, which will actually change the look of the graph a little bit. Let's plot the table of values and hopefully we will be able to spot what the graph will look like. So we're plotting this again on a x and a y axis, okay, between minus 5 and 5, so between x being minus 5 up to the point 5. They haven't gone all the way up in increments of 1, otherwise it just takes too long. Right, let's begin though with x being equal to negative 5, and let's put it into our equation. So y is equal to 10 over, and definitely use brackets here because you've got a negative and you're squaring, so we're doing x is equal to minus 5, and we are squaring it. So negative 5, and then we're squaring it. So that's going to be equal to 10 over negative 5 squared is minus 5 times by minus 5, which is positive 25. So we're doing 10 over 25, which if we cancel that out is going to be, if we divide top and bottom by 5, so divide by 5 and divide by 5, that's equal to 2 over 5, which is equal to 0.4 as a decimal. If you could use a calculator, you could have just whacked that in your calculator to get to 0.4. But that is good. So that's our first y value, 0.4. Your next one, when x is equal to negative 2, let's substitute it into our equation. So y is equal to 10 over x squared, where now x is equal to minus 2. So minus 2 squared. So 10 over negative 2 squared is equal to positive 4. 10 divided by 4, we can simplify it if we want to by dividing top and bottom by 2. Divide by 2, divide by 2, which is equal to 5 over 2. And 5 divided by 2 is the same thing as 2.5. Again, if that's confusing you, put it into a calculator and double check. I'm just manipulating my numbers here to get it to what I want. Not to what I want, but just to make it into a simpler form that I can understand more easily. When x is equal to minus 1, we keep going. This one should be a little bit easier. We're going to get y is equal to 10 over x squared, where x is equal to negative 1. So 10 over minus 1 squared is going to be plus 1. 10 divided by 1 is equal to 10, which is my value here. Good. My next one, when x is equal to 0, so when x is equal to 0, well, again, like on the previous one, I've got 10 over x squared, where x is 0, so 0 squared. So that's equal to 10 divided by 0. You cannot divide through by 0. It is an illegal move in maths. It doesn't work out. So your calculator will say that as an error. Or as we said previously, right, we say it is undefined. It just doesn't work out. So this has no y value. So we keep moving forwards. Let's make that a little bit neater. When x is equal to 1, let's put it into our equation. When x is 1, we get y is equal to 10 over 1 squared. So 10 over 1 squared. So 10 over 1 squared is 1. 10 divided by 1 is equal to 10. So that goes into here. X is 2. We keep going. So y is equal to 10 over 2 squared, which is equal to 10 over 2 squared is 4. 10 divided by 4, again, we can simplify it. The same thing as 5 over 2, which is equal to 2.5, which goes in here. Your last one, x is equal to 5. X is equal to 5. Y is going to be equal to 10 over 5 squared, which is equal to 10 over 25 again, which we've seen before up here, which was equal to 0.4, which is our last solution. So you can see here we've got some symmetry. And the reason is right because if you're squaring something, if you're squaring a negative, it becomes positive, which is why we have 0.4, 0.4, 2.5, 2.5, 10, and 10. If you square a negative, you get the same thing as squaring a positive. So let's go plot these coordinates. Okay, beginning with this first one over here. X being minus 5 over here. Y is 0.4, which is going to be a bit trickier, this one. Increments of 0.2, I think. 4, 6, 8, yeah. So 0.2, 0. No, is it 0.2, 0.4? That's a weird scale. Increments of 0.25, which is a bit of a horrible one. So somewhere about here. It's not very accurate, but that will do as best I can. Minus 2, 2.5 is going to be up here. Minus 2, 2.5 is here. Minus 110 is up here. And let's move that y to over here. In fact, let's put it up to here. Otherwise, we'll get in the way again. X is 0. There's no y value, so I go to the next one. X is 1, y is 10, which is up here. X is 2. In fact, let's just consider, right, these 3 points here. Okay, right. These, you know, actually, let's keep going. Sorry, right. What x is 1, y is 10, goes here. X2, 2.5 for y is going to be here. It's just kind of reflecting, isn't it? 5 and then 0.4, which is somewhere about here. So at this point, some students might think, well, how can I draw this? Maybe it's something that looks a little bit like this. It goes through all my coordinates like this, like this, like this, down through here, like this. Well, does that look kind of like any graph that we know? No, it doesn't. Right. Because it is a reciprocal graph, it's, you know, we know the basic shape is like this. Okay, that's for 1 over x, simply. If I've got 1 over x squared, it's very similar, but basically the negative parts give you the same y values, as we can see, as the positive x values. So really, this graph is going to look, the first bit is the same, but then kind of the same thing reflected along the y-axis. So if we plot these points together like this, using a smooth three-hand curve, there we go. And then through that last point like that, that was drawn, I almost got there in one, but through down there, that's pretty good. And then through down there, like that, there we go. That's the first part. And the second part is just a reflection in the y-axis. So going through my 3 points here, that's not bad. And I keep going, I keep going, I keep going. There we go. That's not very nice, that one. I keep going smooth through those points there, and it would keep going on forever and ever. And that is the graph of 10 over x squared between minus 5 and 5. So with any graph really, you can always sketch it by plotting a table of values. So far up, we've looked at plotting quadratics, cubics, and our reciprocal graphs, which is really good. And we now hopefully recognize their shapes pretty well. So what I can also add on really to this slide is if that's y equals to 1 over x, if we have, let's put it in blue, if we have a reciprocal graph like y is equal to 1 over x squared, it is pretty similar to 1 over x. The first part is the same, but then we get the second part that is kind of a reflection in the y-axis, which is exactly what we had on example 2. Okay, that is it for reciprocal graphs. Thank you.